All right, so we're looking at lesson 4.6. This, as I said, is on page 103 in the student journal. What we're talking about today are complex conjugates. In the other lesson, we learned that if we have a solution like 2 plus radical 3, we learned that 2 minus radical 3 must also be a solution. Whenever we have this kind of an answer, where we have a real part and an irrational part, I should say a rational and an irrational part, then the conjugate of that is also going to be the solution. The same thing's going to hold true with these conjugates for complex numbers. Pairs of complex numbers of the form a plus bi and a minus bi. These are called complex conjugates. They're always going to occur in pairs. And so we know that if 7 plus 3i is a 0, then what else would be a 0? Right. And the other nice thing is we can use the sum product rule on these. So we can use the sum product on these as well as how we just did in the warm-ups on these. All right, so the fundamental theorem of algebra, this says, if f of x is a polynomial of degree n, where n is greater than 1, meaning it's, or greater than 0 rather, meaning that it can be 1, 2, 3, etc., then the equation f of x equals 0 has at least one solution in the set of complex numbers. So all this is saying is anytime we set any function equal to 0, we must have at least one solution. This is actually the more important one though. This one says if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each solution repeated twice is counted as 2 solutions, and each solution repeated 3 times is counted as 3 solutions, and so on. That would be saying this. Suppose I have a function x plus 1 squared times x minus 2 cubed. The degree of this x is really to what power? Second, and this is really to the third. So what altogether would that be then? X to the, not 6, fifth. So this is a degree 5 polynomial, which means it has to have 5 solutions based on this corollary. The way that I would find these zeros is I would set x plus 1 equal to 0. And how many times is that going to be a solution? It's going to be a solution twice. So I would say that x equals negative 1 is the solution twice. What about this one? If I set it equal to 0, what do I get? 2. And how many times is that a solution? And so altogether, we have a total of 5 solutions, which is what this corollary says. What about as far as the graphing goes? If this is a solution twice, what's going to happen to the graph? It's going to, is it going to go through it, or is it going to bounce? Bounce here off the x-axis, and this one is going to go through it. Okay. All right, so here we're just going to identify the number of solutions or the number of zeros. That means the same thing. Very easy. You guys do that on your own. It's just whatever the degree is. What's the degree on this one? It's already multiplied out, so the degree is what? What is it, everyone? 3. So this is going to have 3 solutions. They may be real solutions, they may be complex solutions, but we are going to have 3 of them. What about on this one? Be careful. 4. This is going to have 4 solutions. Okay? The reason why is I would need to put this into standard form in descending order. I could multiply through by a negative if I wanted. Most of the time, this is a positive in front of here. And now I can see that the degree is 4. So when it's all multiplied out, the degree is just going to be this number. When it's not multiplied out, then x squared and x cubed would be getting multiplied, and I have to think x squared times x cubed, bases alike, add the exponents. That's why this was degree 5. All right, let's flip over to page 104. The complex conjugates theorem. This says if f is a polynomial function with real coefficients and a plus bi is an imaginary zero of f, then a minus bi is also a zero of f. This is not in your journal, but just add it in. So the first question is, if 3 plus 2i is a 0, what is the other 0? What is it, everyone? All right. Now in the next part, it says to use the sum product method to find the quadratic equation that results in a solution of 2 minus 5i. So we want to know what's the quadratic that would give us a solution of 2 minus 5i. Well, we already know that if 2 minus 5i is a solution, what else must be a solution? 2 plus 5i. So now we would have to find the sum and the product. So if we add these two together, we would combine like terms. What do we get? 4. For the product, we have to multiply these two together. So I do the first times the first is 4. The outers gives me positive 10i. The inners gives me negative 10i. The last times the last gives me negative 25i squared. So these two are going to give me 0. So this is going to be 4. What's I squared again? Negative 1 times that negative would be plus. So our product is 29. So what that tells me then is that it had to have been x squared minus 4x plus 29 equals 0. That had to be the quadratic that would give me that solution. How can I check it if I don't believe that? What are some methods? Yeah. Graphing it? Sure. Well, if I graphed it though, what would I see? Yeah, it's not ever going to cross the x-axis, right? Because they're imaginary solutions. What if I want to know for sure that 2 minus 5i and 2 plus 5i are solutions? What could we do? I could plug it in. That's kind of a tough way to do it. Couldn't I just solve this problem right here? What's a pretty quick way of solving this? Yep, I'm going to just do it real quick just to prove it to you. You don't need to write it down, just watch. I take half of this and square it, add it to both sides. This is x minus 2. This is going to be negative 25. I take the square root of both sides. What's the square root of negative 25? Plus or minus 5i, right? So I bring over the 2. So I'm going to have positive 2 plus or minus 5i. So 2 plus 5i, 2 minus 5i. See how those are the solutions? Okay? All right, Descartes' rule of signs. We're going to save that for the second part of our lesson. Let's go over here to the last page, 105. We're going to do some of these. So in exercises 1 through 4, find all the zeros. I'm changing the order in which I want to do these. I don't want to do this one first. I want to do this one first. If we're asked to find zeros, that means the first thing we're going to do is we're going to set the function equal to 0. The reason I chose to do this one first is because I wanted to remind you of the ways we can find zeros. The first way you should always try is factoring. So I need to look at this. Are there numbers that multiply to be 49 and subtract to be 48? What are they? 49 and 1. So I'm going to factor whenever possible. The 49 would be minus, this would be plus. So it factored. So now I can set this factor equal to 0, or I can keep factoring. How does this factor down? All right. So once I have it completely factored, I set each factor equal to 0. So this, of course, is going to have a solution of -7. This is going to be a solution of +7. On this one, I'm going to subtract 1. I get x squared equals -1. I take the square root of both sides. What's the square root of -1 going to be in this case? Plus or minus I. So I and -I would both be solutions. So these two would be x-intercepts. These two are solutions, but they don't result in being x-intercepts because i's do not show up when we graph. All right, now let's go back up to this one. The first thing I check is, can I factor it? Can we factor this one? No. So I have to find some other methods. What I want to do is think of my possible rational roots. This is not going away, that whole concept of that P over Q. So I look at my factors of 60. They're plus or minus 1, 2, 3, 4, 5, 6. Lots of them. I'm going to stop there. They're usually not the highest ones. I divide by the factors of 1, but that's just plus or minus 1. So I'm going to have to do this kind of quickly. So I'm going to plug in 1. 1 minus 3 is -2. -2 plus 6 is 4. 4 plus 2 is 6. That's not going to work, is it? Okay, but by looking at these signs, do you think the answer is going to be positive or negative? A positive answer should work, shouldn't it, since we're going to be subtracting? It seems like a positive number should work. Let's go ahead and let's try 2. I don't know if it's going to work. It may or may not. So I bring this down. That's 2, that's 4, that's 1, that's 2, that's 8, 16, that's 18. Nope, it's not going to work, is it? All right, so let's go ahead and let's try 3. Zero, that's 6, that's 18, yay. That's 60. All right, so 3 worked. All right, so we know that 3 then is going to be one of our zeros. So I'm going to jot that down, just put it over here. Okay, but now look what we're left with. We're left with x cubed. So here's what we have now. So again, I want to check, can this be factored? Unfortunately, it cannot be factored, can it? Because this is x cubed, it's not x squared. All right, now thinking logically about this one, could it be a positive number now that's going to give us an answer that's going to end up being 0? Could a positive number give me 0 in this case? It couldn't, could it? So I'm now going to check a negative number. I'll do -1 just by my, in my head. -1 minus 6 is -7. That's not going to work. -2, I can do this without synthetic. That's -8, -8 minus, ooh, that's going to work, isn't it? All right, so now I need to use that, so I'm going to use it. So -2 seems to have worked. Don't forget the 0. Bring this down. That's 1, that's -2, that's 4, that's 10, that's -20. All right, so now I know -2 is also going to be one of my zeros. All right, so now what I've got then is I've got x squared minus 2x plus 10 equals 0. Are there numbers that multiply to be 10 and add to be 2? Multiply to be 10, 10 and 1, 5 and 2, do they add to be 2? No, so what am I going to have to do? I'm going to have to either use a quadratic formula or what else? Completing the square. I'm going to complete the square. I think it's faster. So I'm going to take half of this and square it. That's going to be 1. So I'm going to add 1 here. This is going to turn into x minus 1 quantity squared. This is negative 9. Now I have to take the square root of both sides. So I get x minus 1 equals plus or minus 3i. So my other answers are going to be 1 plus 3i and 1 minus 3i. And those are going to be our 4 solutions. Okay? Difficult stuff, but it's something that if you work on it enough, you're going to get the right answers eventually. It's just that synthetic division. You don't always get it right the first time, and you got to be persistent and keep working it. We're going to save number 3 for later after we do Descartes' law of signs, because it'll kind of narrow our choices down a little bit. Let's come down here now. Write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. So they're telling us these 3 are the zeros. Any ideas on what we can do? How we can get that polynomial function? Anybody know what to do?
Can we just plug them in like x plus 4, x minus 1, x minus 7?
Yeah, you can do that. You can just literally write it out like this. That has to equal our function. And now we have to multiply it all out. If these are zeros, we know as a factor they had to be this. So I could then multiply it out. Try to do this quickly, guys. So this would be the function. Now, maybe we feel like, oh, I'm not sure I did that right. Well, watch what I can do to check. I'm just going to put in this function in my calculator, because I did that kind of quickly. I'm kind of hoping I made a mistake just so we can see what it looks like. But let's go to the table and look. So if we did this right, then negative 4 should be a 0. And it is. 1 should be a 0, and it is. And 7 should be a 0. Okay, so I did it right. Okay, but if I didn't get those answers, then I would know I need to go back and check my multiplication. All right, we're going to do this one now. Does anybody have any other ideas on how I could have done this a little bit quicker? What?
Could you have plugged it in a calculator?
Not really. The calculator doesn't know how to multiply that all out.
What could you plug to the table and put the zeros in? That would work, and then, or can you not do that?
The only way I can think of, there actually is a way you could do it. It's not under table. It's actually under, remember how we would put these in under our stats? So if you went under stat edit, let's just see if this works. I really was not thinking of this way, but I think it might be okay. So if I put in my zeros, negative 4, 1, and 7, and I put in 0, 0, 0, and now I do a stat calculate a cubic. Yeah, that should work actually. Let's see what it does. Oh, gradient mode. What? Let's see. I don't know why it's not liking that. It's saying that I have something else in there, but I don't. I think it's because we're not giving it really enough points to really be able to figure it out.
Okay.
Because
it could be going like back that way.
right, that's the problem. Like it needs a higher low point, I think. I want to see that error message again though, because that didn't really make sense. Why? Value entered is not allowed in the function or command. Radian mode tangent pi over 2. Radian mode. I don't know, for whatever reason it's thinking that this is a trig function.
Are your pause triggers on? Does that matter?
That shouldn't matter really. I can turn them on. But see, here's what Zach's saying is like, if I look at these now, if I do a zoom stat to be able to see those, gosh, it doesn't like this at all. I don't know why. I think it's just because these points aren't really, they're all in a row. If you visualize this, okay, fine. If you visualize this, it's going to be 3 points in a row, and it doesn't know which way to go with it or anything. So, okay, but here's what I was thinking, guys, is what about if I just took these two and I did my sum product? What's the sum of those two? -4 and 1. What's the sum? -3. What's the product? -4. Do you see how I could have gone directly to this? See what I mean? That's what I was thinking. Instead of actually multiplying that out, I could have used these two, gone directly to this, then added in that one and gone with it. Okay, so that's kind of a nice thing too. All right, so let's go down. We're just going to do number 7. We'll come back here and do 8 a little bit later. Okay, so they're telling us that 8 is a solution and 3 minus I is a solution. What's another solution? 3 plus I. I know that one of my factors would have to be x minus 8, but with this, I really don't want to do that x minus 3 minus I, that kind of thing. Foiling that out is no fun. So let's do our sum and product. So what's the sum of these? 6. And now let's find the product. So we do the first is 9. I'll come up here. The outers are positive 3i. The inners are negative 3i. Those cancel. So it's 9 minus I squared. What's that going to be? 10. Do you guys know why it's 10? I squared is -1. Okay, so I know that that then is going to have to be x squared minus the sum x plus the product. And so now I'm going to multiply that out. And so our answer should be x cubed minus 14x squared it's not going to like these plots being on. And so I'm going to check it. And I don't advise you to check these on every single quiz or test we take, but if you have time, you know, it's worthwhile. So all I should see here is a 0 at 8. And I do. I have my 0 at 8. I shouldn't see any other zeros because these two zeros are imaginary. And if I graphed it, oh gosh, it hates those values I put in there. And if I graph it, I should just see one x-intercept. It's down here at 7. Okay? Does that all make sense to you? All right, guys. We're going to stop there, and we'll continue a little bit later, the rest of this.